At first, Happy New Year! May the new year bring countless blessings to you and your family, and wishing you a year of happiness and good luck. So, Happy New Year again. Today I will discuss some question of calculus of variation, because I have told you many times actually calculus of variation is very important for higher study. Our first question, find the extremal of the following functionals. Here the extremal given as I(y)x equal to integration a to b y double prime whole square minus y square plus x square dx, which satisfies the conditions. Here the given initial condition y0 equal to 0, y prime 0 equal to 1, y pi by 4 equal to y prime pi by 4 equal to 1 over square root of 2. And here given the functional f of x comma y prime comma y double prime equal to y double prime whole square minus y square plus x square. Since here y double prime exists, so we all of us know the Euler equation would be del f del y minus ddx of del f del y dash plus d2 dx to del f del y double dash equal to 0. Then that implies del f del y means obviously minus 2y. Here this part would be 0, that means plus d2 dx to del f del y double dash means d2 dx to 2y double dash equal to 0. That imply 2y to the power 1/4 equal to 2y. So just cancel 2 both sides. Then this imply d4 minus 1 y equal to 0. Therefore, the equation of this differential equation we all of us know, since the root is plus minus 1 and plus minus I, so the equation would be c1 e to the power x plus c2 e to the power minus x plus c3 cos x plus c4 sin x. We all of us know this is. Now, notice the initial condition, then apply the y0 equal to 0, first initial condition. So that implies c1 plus c2 plus c3 equal to 0, and y prime equal 0 equal to 0, that implies c1 minus c2 plus c4 equal to, sorry, here not 0, here 1. Y prime 0 equal to not 0, here 1. Third initial condition, y pi by 4 equal to y prime pi by 4 equal to 1 over square root of 2. After putting this initial condition, 1 over square root of 2 equal to c1 e to the power pi over 4 plus c2 e to the power minus pi over 4 plus c3 1 over square root of 2 plus c4 1 over square root of 2 equal to 1 over square root of 2. Then c1 e to the power pi over 4 minus c2 e to the power minus pi over 4 minus c3 1 over square root of 2 plus c4 1 over square root of 2 equal to 1 over square root of 2. And by putting all initial condition and calculating, I will get c1 equal to c2 equal to c3 equal to 0 and c4 equal to 1. And since c4 equal to 1, therefore yx equal to sin x, this is the given functional of this extremal. I hope my all viewers have understood this question easily. Okay. Our next question, which had come CSIR net exam The question is, consider the functional. And this question is very interesting. Here, just at first I will highly recommend you, at first see the question with pay attention, because this question is very interesting and very important for higher study also for any competitive exam. The question is, here the functional is 1 plus y square over y prime whole square for admissible function yx. Obviously, this function is absent of x, and when the functional is absent of x, then we all of us know the Euler equation is f minus y prime del f del y prime equal to constant c. This would be the Euler equation. Next, options are very important. Notice, which of the following are extremal for this functional? Option 1, yx equal to a sin x. Option 2, yx equal to a sin hyperbolic x plus b cos hyperbolic x. Option 3, yx equal to a sin hyperbolic ax plus b. Option 4, yx equal to a sin x plus b cos x. Which of the following be the extremal of this functional? Notice, at first solve the functional. The equation would be f means this 1 plus y square y prime whole square minus y prime, and del f del y prime means obviously minus 2 1 plus y square over y prime whole cube equal to constant c. Now just calculate. Then after calculating, this value would be 1 plus y square over y prime whole square. Here minus and here minus, plus 2 1 plus y square. After cancelling, this value would be y prime whole square equal to constant c. That imply 3 times 1 plus y square over y prime whole square equal to constant c. And from this expression, 3 over c equal to y prime whole square over 1 plus y square. And that imply y prime over square root of 1 plus y square equal to square root of 3 over c, and consider square root of 3 over c equal to constant a. Then we all of us know y prime over square root of 1 plus y square means obviously sine hyperbolic inverse y, and here after integrating, this value would be ax plus b. So y equal to, that imply y equal to sine hyperbolic ax plus b. Okay, therefore obviously the equation would be such type y equal to c times sine hyperbolic ax plus b. So option 3 obviously right option, and this is just after calculating this value obviously true. Many students will be fault here. They will think only option 3 is a right option. But not only option 3, all option be right. Why? This is the interesting thing of this math. At first I will see why option 2 is right option. Then I will see also other option be true. Here I have got This is the extremal of this functional. Sine hyperbolic ax plus b. And we all of us know sine hyperbolic ax plus b means sine a cos b cos a sine b. That means sine hyperbolic ax cos hyperbolic b plus cos hyperbolic ax sine hyperbolic b. Okay? And obviously this part and this part be constant term. So we can write this as consider this is, since this is constant, consider this is e sine hyperbolic ax plus consider this is f cos hyperbolic ax. Okay, and notice option 4 given a sin x plus b cos x be the extremal of this function. Now put a equal to 1. By putting a equal to 1, notice here the extremal would be a sin hyperbolic x plus f cos hyperbolic x. Yx equal to e sin hyperbolic x plus f cos hyperbolic x. This is be the also extremal, which I have got our main extremal of this functional. That means option 4 also right option. Okay, sorry, not option 4, option 2 is a right option. Now I will see option 4 and option 3 also, option 4 and option 1 also be right option. Notice we all of us know sine hyperbolic ix means I sine hyperbolic x, and cos hyperbolic ix means cos x. We all of us know this part. Therefore, by this expression, since option 4 indicate the extremal is a sin x plus b cos x, for this consider a equal to I. Then this reduces here a equal to I, that means here sine hyperbolic ix, and obviously sine hyperbolic ix means I sine hyperbolic x, and since here cos hyperbolic mean hyperbolic b, consider cos hyperbolic b is any constant. So consider this is this constant is e, and since here I have considered a equal to I, that means cos hyperbolic ix, and cos hyperbolic ix means obviously cos x. Notice, therefore this is cos x, and obviously sine hyperbolic means mean consider this is any constant, consider this is f. Therefore the equation would be, since I is any constant, so consider ei equal to new constant d sin x plus f cos x. So notice this part same as option 4, a sin x plus b cos x. That means option 4 is a right option. And notice option 1 is similar type, but here has told a sin x, only a sin x be the extremal of this functional. For this, here also extra part, consider a equal to similar to before I, and extra b equal to 0. If we consider a equal to I and b equal to 0, then from this expression we can write yx equal to sine hyperbolic ax. Since b equal to 0, that means cos hyperbolic 0 means 1. Only I will get, a equal to I, that means here sine hyperbolic ix, and sine hyperbolic ix means I sine hyperbolic x. And consider this part I be constant, so consider this is capital A, I equal to constant capital A sin x. So A sin x be the extremal of this functional, because here I have got A equal to I, B equal to 0. Since B equal to 0, so obviously this part would be 0, because sine 0 means obviously 0. Sure, so option 1 is also right option. That means option 1, option 2, option 3, option 4, both are the functional of this extremal. Have you understood now? Our next example, which had come CSIR net June 2023 exam. The question is, this is the extremal and the given extremal is yx whole square minus 4yx y prime x plus 4y prime x whole square. And this extremal subject to the condition y0 equal to 1 and y prime 0 equal to half. Then the question, which of the following statement are true? Option 1, y is a convex function. Option 2, y is a concave function. Option 3, yx1 plus x2 equal to yx1 times yx2 for all x1, x2 belongs to close 0, 1. Option 4, yx1 times x2 equal to yx1 plus yx2, and this is true for all x1, x2 belongs to close 0, 1. Which of the following be the true? That means actually our question is extremal would be convex, is extremal would be concave, is extremal satisfy this relation, is extremal satisfy also this relation, which would be true. Okay, notice here the given functional is this. Here the functional is y square minus 4y prime plus 4y prime whole square, and obviously this satisfy the Euler equation del f del y minus ddx of del f del y prime equal to 0. Del f del y means obviously 2y minus ddx of del f del y prime means minus 4y plus 8y prime equal to 0. That imply 2y plus 4y dashed minus 8y double prime equal to 0. Sorry, here I have done one thing wrong. Del f del y means 2y, not only 2y minus 4y prime. That means this would be cancelled, so this equation would be 2y minus 8y double prime equal to 0. That imply y double prime minus 1/4 y equal to 0. So the auxiliary equation is m square minus 1/4 equal to 0. That imply m equal to plus minus half. So yx equal to c1 e to the power x over 2 plus c2 e to the power minus x over 2. This is the solution of this equation, which satisfy the initial condition, here the initial condition given y0 equal to 1 and y prime 0 equal to half. For this, since y0 equal to 1 and y prime 0 equal to half, therefore that imply c1 plus c2 equal to 1 and y prime x means obviously c1 half e to the power x over 2 minus c2 half e to the power minus x over 2. Y prime 0 equal to halves. This means half equal to half c1 minus c2, that imply c1 minus c2 equal to 1. So, one condition c1 plus c2 equal to 1, another condition c1 minus c2 equal to 1, that imply 2c1 equal to 2, that implies c1 equal to 1. And if c1 equal to 1, that imply c2 equal to 0. So, the functional is yx equal to e to the power x over 2. This is our given functional. And here the condition given convex and concave. We all of us know if y double prime x is greater than 0, then the function is always convex, and y double prime x is if less than 0, then this is the concave function. Y double prime x equal to obviously 1/4 e to the power x over 2, and notice y double prime x always greater than equal to 0 for all x. So obviously this function is convex function, because this is greater y double prime, when y double prime x is greater than 0, then this function is always convex function, we all of us know. Next, y x1 plus x2 equal to e to the power x1 plus x2 over 2, which is equal to e to the power x1 over 2 times e to the power x2 over 2, and obviously this is yx1 times yx2. That means yx1 plus x2 imply yx1 times yx2. I hope my all viewers have understood. That means option 3 also right option. That means option 1 and option 3 is a right option. I hope my all viewers have understood this question. Okay? Oh well. Today I will stop here. In my next video, I will discuss again this type of question, because I have told you many times this type of example actually very important for any competitive exam. Okay? See you soon. Stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.